All right. Again, thank you very much for joining us. Today, I'm a facilitator. My name is Casey. Right. And welcome to the Cloud 201 series, the webinar that we do for our members over here. And I'll be a facilitator. I'll be muting the participant for this call, and you will leave the call, leave the answer at the end of the call, leave the question and answer at the end of the sessions. All right. Or you can post your question onto the chat group. All right. And today, unfortunately, Dr. Anton, who is the president of SES Cloud Computing chapter, he can't make it for these sessions, right? And I'm doing the welcome speech to everybody. Our cloud computing chapter, our main objective is to bring cloud computing, the latest of the cloud computing, to the participant over here, so that now they can know and understand the latest stuff from area, right? And today we are very happy to have a representative from Teradata, right, to share with us some of the vision analytics that they see in the cloud area, or some of the use cases the Teradata team is doing, right? And it'd be great that they can leverage on the cloud area to do this in the vision analytics in the cloud, right? And today we have Mr. Yam Guan, who is a business consultant from Teradata side, and join with me also here is Dr. Salman, right, who is the data scientist and the practice lead in Teradata. And they'll be sharing the session what they do in the cloud technology area, how they implement vision analytics in this new COVID-19, right, the new norm. How do they assist customer and use cases using cloud technology to look at vision stuff, right? And without further ado, I'd like to hand it on to the Teradata team to talk through this thing on the vision analytics in the cloud. Right, over to you, the Teradata team.
Thank you, Casey. Hi, everyone. Again, thank you for joining us today in this webinar. So I'm a business consultant from Teradata. So in my role in Teradata, basically my focus is I'm working on data-driven IT transformation initiative, helping our customers achieve their desired business outcomes. Just to set some context prior to moving into vision analytics in cloud, I would like to first share briefly about Teradata COVID 360 platform. So this is an initiative which our team has embarked on in putting together for the past couple of months. So this is a platform that's helped to drive situational awareness and actionable intelligence, which I'll be covering in my session. And of which vision analytics is one of the use case that has been driven out of this COVID 360 framework. And then Dr. Salman will be going in deep dive in covering this portion later. So what we recognize in this COVID situation is that it's impacting everyone globally. We know that this is not something that is like going to go easily anytime soon. And it has been evident that a new wave of outbreaks has been happening.
Let's say
Countries such as Hong Kong, Vietnam, Australia, and even if a vaccine has been found, the mechanism to get this cure out to the hands of everyone is not really trivial, and it's likely going to take tremendous time and effort to do that. So as the world is adjusting to the new normal, we know that as a technology provider, there's actually tremendous capabilities, potentials that a data-driven IT platform can help government agencies and businesses navigate into a new normal as we weather through this lengthy recovery journey. Some of the capabilities that we foresee a platform will require include real-time data collection, risk scoring, advanced analytics to enable real-time insights. On top of that, a 360-degree awareness of the situation and the actionable insights that follows will be crucial to weather through this storm. And of course, cloud computing also plays a crucial role as an underlying technology in enabling businesses and government to quickly apply this actionable intelligence to respond to the crisis and maintain business continuity. This unprecedented pandemic has in some ways spurred the adoption of cloud services across all industries, especially when companies are actually pivoting to support remote work and collaboration. And even in healthcare providers in the front lines, we also see that there's an increased adoption, basically to leverage cloud for remote access, cloud analytics to scale their operations. here we are trying to share is our approach in handling this outbreak response. We divide them into 3 major phases. So in our check phase, it's more about around identifying infected high-risk individuals, understanding their movement patterns, and doing risk profiling of individuals and geographical risks. In our containment phase, appropriate geofences that have been set up. We look at supply chain of critical supplies, such as PPE and test kits, identify key weakness of the chain, ensure that stock-up situations is not happening or minimized. We also look at predicting onset of critical illness that has an effect of COVID. So basically, the impact on critical resources such as ICU beds can be minimized. Finally, we look at restart phase. So basically, this is the resumption of economic activities and as countries start to reopen their borders and travels. So continuous monitoring, early detection, early warning is really essential to curb a new wave of infection. Surveillance mechanism such as vision analytics can help in terms of crowd monitoring, enforcing social distancing measures. All this will move us towards a recovery phase as we move into a new normal. So now let's take, for example, in the track and contain phase. There are a variety of data sources to examine, in particular, their population mobility data. And this could come from your tree data set, telco data, mobile app data, and so forth. There's also point of entry registration data set, hospital encounters, and so forth. And moreover, having an understanding of the zonal information, zonal land use information is also crucial. Whether a piece of land is demarcated to be a residential area, a shopping mall, or a park, and the movement patterns of infected cases will make a significant difference in developing geospatial analysis on risk exposure model, and also allow us to uncover insights to the pandemic spread. Ultimately, it's all about having all these set of data being stitched together, having a multi-source, multi-structured data set, and then enable analytics and actionable intelligence thereafter. In the example of vision analytics, the multi-structured dataset can encompass observational video feed from CCTV, customer demographic information from CRM systems, and we can also get customer habits and behaviors from point of sales data. So in this diagram, you see an infinite loops of events that's happening. So this pretty much follow closely the control concept developed by the military. So we are applying to our framework. So on the left-hand side of this loop, you are seeing the preparation, data preparation stage, where data acquisition is happening. So the acquire, curate, and integrate. So basically, this is about getting rid of data quality issues, standardizing the terminologies, filtering important or relevant data set through business rule engines. Basically, ultimately to derive an well-integrated multi-source golden record of data that can be trusted. Right? The strong set of integrated data provides the foundation of doing data analysis, driving insights by discovering patterns. And on the right-hand side of the loop is where businesses, government agencies are looking to achieve. These are where the business outcomes, business values are driven. So observing, reviewing through critical events and patterns, applying data science techniques to predict and make forecasts based on various scenarios, finally making a set of recommendations and taking the best course of actions. And of course, activating the actions and communications with the relevant stakeholders will be also very important. So taking this example back to our vision analytics, having a well-integrated data set of observational video feed, customer demographic, and point of sales data could actually empower businesses to observe and act upon it, achieving their required objective and KPI, such as ensuring crowd safety through social distance observance and mass monitoring, and also improving customer experience by understanding customer dwell time and crowd heat map monitoring. So once we have this data set and events stitched together, we will be able to model what-if scenarios, understanding population mobility patterns, leveraging advanced analytics and models for early warning signs, surveillance monitoring, and we can use this to monitor individuals' geographical risks, crowd safety, and well-being of workforce. Ultimately, actionable intelligence is all about having that necessary information available, the intelligence that can be acted upon in order for anyone to deal with the situation on hand. This will provide government agencies and businesses to take action accordingly, which will be important as we move towards the restart of the economy, reopening of borders, and tourism. As part of the COVID 360 solution framework, we had actually identified around 50 use case areas. A couple of the ideations actually come from our global hackathon, which is initiated within Teradata. We had actually collected around 100 ideas being submitted by our employees. A couple of them has been shortlisted, prototyped into demoable assets. Some of them are actually in POC stage with our customers, and the few has even went live. Here in the slides, you will see some of the sample focus areas and use case areas that we built around our COVID 360 framework, including vision analytics. On the very first use case on the left pertains to the health and wellness of healthcare frontline workers. This helped us to tackle the overburdened frontline workers' emotions and wellness, basically by providing a wellness score of each employee. This is to avoid employees from reaching a breaking point and jeopardizing their health and work performance, as well as patient safety under their care. In the second focus area is around clinical care optimization. In this use case, we actually look at early warning system for COVID patients who has a strong likelihood of admitting into ICU. So in this specific example, we actually look at predicting the onset of cytokine storm. So cytokine storm is actually a condition where the human immune system went on an overdrive due to a threat of viral or bacterial infections, and then basically attacking everything inside, including the healthy cells in the body. So why is this significant? It's because the mortality rate is expected around 50 to 80%, and it's also suspected to be killing around half the severe COVID-19 patients. On top of that, this condition not only affect COVID, but also non-COVID cases, such as dengue fever, sepsis infection, flu, and implant rejection. So having such an early warning systems can help to alleviate ICU bed crunch, also improve patient outcomes, as well as reducing the cost of care. Next, we also look at the healthcare readiness effort. We looked into supply chain optimization of critical supplies, such as PPE and PCR test kits, and ensuring the availability of all these resources at the right place at the right time. Finally, we also leverage on vision analytics as part of our monitoring and surveillance framework. So now I will pass this over to Dr. Salman, who will be speaking on vision analytics use case and how it can help with crowd and safety monitoring during these unprecedented times. Over to you, Dr. Salman.
Thank you, Yamgon. So let me just share my slide screen, and please do let me know when it's visible.
Yes, visible.
Thank you. So I am a principal data scientist and practice lead for the data science and BI teams in Data GDC. And today I'm going to be spending the next 20 or 30 minutes looking at how we can use AI in the cloud to transform the enterprise today in a retail context. The objective is to cut through the hype and examine real-world approaches and of applying AI on the cloud at scale to drive answers. My objective is to have given you an idea how we can enable companies to get to an AI first future. So over the last decade, AI has experienced a renaissance, particularly in the last few years, fueled by advances in the research and applied research communities, more distinctly around deep learning. poised to disrupt industries as we enter the new decades. Deep learning is already providing early adopters with answers to their most challenging and important questions in a variety of industries, such as finance, supply chain, telcos, or airlines, as well as manufacturing. What we see here is that the breakthroughs in AI have really centered on two essential parts. These two parts, when combined, allow us to make increasingly accurate predictions, leading to better answers. The first part is more data, where we are seeking more perspective through additional features and dimensions of data that describe all aspects of our business. We'll talk about this a bit more here in a moment. Now, with this expanded perspective of data, we can apply more learning algorithms, which have advanced tremendously over this decade. Driven by open source innovation, these learning frameworks have removed the cost barrier and, in many cases, are replacing traditional statistical based algorithms with AI. When applied correctly, generating significant lift by allowing us to extract hidden signals or patterns in our more data to provide better answers. So, this overall process needs to be underpinned with the strong architecture. Where we have been falling short is being able to provide that architecture where we could have a combination of cloud edge-based infrastructure, as well as GPUs and machine learning solutions, all integrated with automation and deployment. There are many considerations that we have to account for. How do we design an architecture that provides compute environments across the edge, cloud, and within our enterprise data centers that can solve both batch and real-time scenarios? How do we get access to GPUs in order to accelerate training our models and applying inference at scale? How do we blend traditional machine learning techniques and combine various neural networks to automate the labeling and extraction of features? How do we manage the overall model lifecycle and consider model risk management principles such as avoiding model bias in production? While each of these challenges are daunting, they can be overcome and addressed. The essence of what enables better answers is a robust data foundation that allows these predictions to reliably occur at scale. A paradigm shift is happening. Rather than programming with software using data, we are now programming with data using software. When we are programming with software using data, we provide the understanding and logic in software that is supplemented by data. In the future, we specify an outcome where the understanding is buried in data, so the programming will take the shape of learning and optimizing things from the data, guided by using software. So, as over the last 40 years, we've captured transactions from operational systems that now provide a highly curated data set that leads high value. Then, over the last 20 years, we've been focused on understanding the high velocity data of interactions from mobile devices, web, and social media. Interactions are human generated and can record human decisions, such as watching a show on Netflix, playing a video game, texting, browsing. Over the next 20 years, though, our data understanding will be shaped by our ability to extract value from previously intractable data sets. Such as images, audio, video, speech. These observations are machine generated and proliferating. They observe the behavior of humans or it's not just, this seems to be some background noise. Yeah. It's not just the domain of Silicon Valley tech giants here, such as identifying people in pictures for tagging Facebook. Most of this information is already hosted on the cloud. How to develop and optimize AI solutions that integrate with and leverage this cloud-based collateral while being scalable and performant is a key design question. So you have this data, IoT data, you have various different types of data streams already available and streaming on the cloud. High resolution line scan cameras capture different stages of the manufacturing fabrication process. CCTV recording is available to catch traffic patterns in a smart city. Audio recordings from rotating machinery in planes and trains. Retail store surveillance video for loss prevention. Camera, LiDAR, and radar from vehicles providing driver assistance or even autonomous capabilities. Drone footage to improve safety and yield in the agriculture and energy sector. So How do we use all of this data to improve our businesses? The idea is to shift our understanding on how we apply more learning algorithms onto more data in a real world scenario. How are we focusing on improving customer satisfaction while reducing the cost to serve within a retail context? But these concepts have broad applicability across many industries. Right now, we'll have a look at two videos in a retail store as well as a retail branch and walk through specific details and subtleties of how to apply these learning algorithms. What's fundamentally different here is that we're using state-of-the-art AI techniques based on industry best practices that cover data that over which data can be live streamed over the cloud or processed in batch mode, allowing us to understand what customers are doing across time and space in a physical location. We will then build up on this understanding in an effort to drive better answers. So what you see here is a video where we are looking at a 45-degree camera view where we see two types of subjects, customers and associates in the appliance department of a retail store. We want to have awareness on how the physical space is being interacted with, specifically which products are driving engagements. Some highlights to pay attention to here is the couple on the left that you see that on the left side hand side start by doing a walking activity down the aisle, forming a path. As they get to the end of the aisle, they start an engage activity with a specific product SKU. On the other aisle, we see an associate customer page that are a pair that are in an engage activity. Note that everyone is assigned a temporary session ID, and since we don't use biometrics, once the faces are detected, they're blurred. Lastly, the added complexity of a PTZ camera means that we have to compensate for the movement of the camera as we determine subject pathing and activity. So this gives you a reflection of some of the insights that we can gain. Here, in this case, though, what we're looking at is a retail banking scenario where the camera is in a lower location of the store, which introduces some complexity as there are more occlusions in the image space. In a branch, walkouts are a key concern as customers queue waiting for banker or teller. We see two tellers behind the counter, three customers queued in a line, and a customer banker pair on the couch. We will see customer number 5 walk onto the counter, engage with the two tellers. Re-identification is an important part as the customer passes. This is customer number 4, though. So as the customer passes in front of the teller. So after the transaction, we can see that our customer is right about now really satisfied. So we should better understand what was the nature of this transaction and how we can replicate that customer experience to ensure that we are providing better and better service, which is just gives you an idea of some of the insights and the value that we are trying to provide here. So before we go into diving into specific details of how to apply learning algorithm techniques in a retail store and a retail brand setting, we need to talk about privacy, ethics, and compliance. As we now have the ability to have a better situational awareness in the store, we must balance these capabilities with regulations and privacy expectations. From the onset, privacy, ethics, and compliance must be a first-class concept, and we should ensure that the right controls are in place to prevent unintended abuse. Let's take a look at the more learning algorithms processing pipeline where we leverage industry best practices and emerging frameworks for rapidly extracting features from observational data. So first, we need to baseline our understanding of the existing store performance. This could include the overall sales, inventory, payroll, finance, and operational reporting. Also, we need to calibrate our approach based on understanding the technical capabilities of our retail environment. That can be applicable across thousands of stores. So second, we want to effectively detect subjects in our retail environment using multi-camera, multi-object fusion techniques. We've trained different CNN architectures for subject detection. Third, we detect subjects in every frame. So the objective here is that we can form a temporary session ID and use re-identification to form a path so that we can associate a session with a subject for the duration of time that they are in the store. We then apply a classifier to determine what type of subject is detected, associates, security, manager, customers, bankers, tellers, and so on. it depends upon the nature of the domain and the application and where we are deploying the solution. Next, we apply physics-based and deep learning models to pose detection and for pose detection and proximity detection to understand what activities are being performed. These activities include walking, queuing, dwelling, product engagement, associate engagement. More importantly, we can now run A/B experiments using A/B test concepts to change product placement, product mix, run promotions, change planograms, and understand impacts on store performance, which is pretty relevant in terms of business impact. Next, what we need to do here is what we're doing here is taking a closer look at the vision metadata that we derive from these features. Essentially, we are deriving structure from unstructured sources to determine subjects performing an activity projected into an XY coordinate plane within the physical space. The time series data will capture movement around the store at a once by 7th second interval, given that we have 7 frames per second coming from our cameras. The highlighted rows show the transition of a customer walking to engaging with a specific SKU as illustrated in our appliance example. While this is interesting, this simply tracking and classifying the motion of subjects in a retail location in the absence of retail context is of limited value, showing an incomplete picture. So what we do is that we look at other sources of data which can enrich and enhance the metadata that are that metadata or the outputs of the observational inference that we've done using our deep learning models. As we connect the vision metadata with other dimensions of understanding, we get a richer context on how customer behaviors are influencing our stores performance. It's important to note that we don't directly link between vision metadata and customers, but rather we apply a distinct set of controls aligned to privacy policies and ethics, so that we can ensure that the regulatory requirements are met as we move forward. With this context, we can now start to answer specific questions, such as how does customer engagement and queuing times impact store sales? How do marketing promotions influence conversion rates in the store? So each of these are specific questions that a retail operations manager would ask. And we are coming up with specific KPIs that help answer those questions. So this can help us understanding relationships, for example, between wait times and engagement. More specifically, how does the relationship influence conversions or walkouts? We can provide more definitive answers, such as moving products to a new location based on customer engagement and footfall traffic, as well as related product sales. Another answer to improve store performance could be increasing staffing in a specific department based on a promotional campaign, given the high wait times traditionally in that specific department. So all relevant questions, all being provided answers to through continuous pervasive data intelligence, bringing together analytics at scale across all of your traditional transactional, interactional, and observational data. Pervasiveness is about a complexity reduction and ubiquity. Treating this data as a domain of a single organization that resides in a silo restricts value. Instead, the observational data should be pervasive across the organization, such that facilities management, marketing, and others can easily find and share and connect with this data. Using the hybrid edge cloud-based deployments that we've worked with, we've seen, which can be both public and private, anyone with a basic working understanding of a BI tool can begin to benefit from the breakthroughs unlocked by AI. By applying pervasive data intelligence in a retail context, we are now better equipped to improve our customer satisfaction while reducing the cost to serve. Now, how do we do that? Opportunities now emerge to improve customer satisfaction, such as optimizing the floor plan based on path traversal, reduce walkouts by engaging customers earlier, improve operational efficiency by uncovering best practices, and vetting next generation concepts of interactive digital mechanisms in the store. Similarly, how do we reduce the cost to serve? We now have opportunities to optimize the staff scheduling and deployment based on dwelling and queuing rates, improve staff productivity, and improve training through quantitative measures, building better staff forecasting models through customer behaviors, and promoting self-service digital offerings on a mobile web channel by understanding in-store activities. So to underpin all of these answers, we utilize the architecture that you see here now. So these opportunities we've seen are best addressed through a hybrid edge cloud architecture where trained models are deployed for inference on an edge computing infrastructure acting on observational data coming in from integrated video streams. The operational metadata is extracted and piped to the cloud where it can be processed further and combined with other data streams, providing additional dimensions of understanding as we talked about previously. Simultaneously, the video streams in their raw form are also piped to video storage on the cloud for annotation and retraining of the deployed models at specific intervals of time. Updated models are then pushed back to the edge to perform improved inference on observational data, creating a continuous integration, continuous deployment cycle supported by a cloud-based deployment of customized analytics ops solutions that we've developed based on which focus on automation and data transformation and ingestion, as well as model serving and scoring, monitoring performance on a continuous basis. They utilize an open source microservice architecture that can be deployed in Azure, AWS, and moving forward on Google Cloud as well, which integrates seamlessly with cloud-based deployments of data processing and analytic engines such as Teradata. They can be others as well. So this entire deployment, it's underpinned on a variety of cloud architectures depending upon the availability of the relevant compute and storage capacity. This architecture has flexibility in terms of the GPU infrastructure required for deep learning model deployment and development. It supports common technology stacks such as the NVIDIA Metropolis and the Intel OpenVINO toolkit, which is available with major cloud service providers. Now, if we look at it from a layered aspect, so we have data streams, observational data coming in both in streaming and batch mode, and we have APIs or SDKs available for operational integration, plus a user experience dashboard that can be in a variety of technologies. We've used Dash, we've used Tableau to visualize the KPIs that we've developed on top of the metadata and the transactional data that's present in the enterprise warehouse to provide specific insights, exemplified by some of the ones that I just talked about. So we then have the application layer where the analytics ops, the operationalization solutions are in place for automation. Then we have the analytic engines for deep learning, machine learning, and SQL analytics if required. The integration is over a high-speed fabric while the storage is over either cloud or on-prem based storage architecture. So most of the solution components are Dockerized, and they can easily be deployed on-prem or on cloud based on requirements. We've seen that flexibility is at times required. A cloud-only solution might not be feasible in situations where you have regulatory constraints in place, such as in financial domains, in some cases in the telco domain as well. So that flexibility is required. In some cases, you do need to do an on-prem deployment combined with edge computing, where the data is flowing into a centralized data center if required. So this just gives you a quick overview of some of the solutions that we have, the architecture we have used to develop this solution, or make it easier to scale up similar vision analytics-based solution. A specific use case relevant to the current scenario, with the current pandemic making the cost of business higher, and as most economies open up, they need to fulfill certain health, safety, and regulatory requirements before they can start doing business relatively normally. As part of this process, we are also integrating this solution with our return to office policies, where we are integrating data, things like employee badge access logs, enterprise Wi-Fi log attributes with the camera metadata attributes to do things like traffic analysis, trying to monitor adherence to social distancing and mask wearing, trying to see whether facilities are being cleaned and disinfected and in a regular manner. I would some examples of these would be given in the demo that I'll follow this up with, just to give you an idea how a lot of these models can be repurposed. And in general, we've developed a series of use cases where with minimal repurposing, a lot of these models are already being used to address use cases, COVID specific use cases, such as trying to identify the number of customers who are waiting indoors or outdoors to be served, whether they're carrying out social distance observances, whether how customer tracking and walkouts in this scenario, given the larger wait times expected, is affecting the overall business, whether employees or customers are wearing masks or gloves. Again, whether specific areas are being cleaned or disinfected regularly or not. Similarly, an extension of this would be COVID symptom detection model, where we're trying to identify employees, contractors, and customers who demonstrate physical symptoms, such as struggling to catch breath or being feverish, and automatically tag them as risks. So here I will cycle into a demo of our solution, where this is developed on top of video streams coming in from the Teradata Cafe. So since due to confidentiality constraints, we can't share the actual solutions on top of customers' video streams. We've gotten the relevant permissions to do so on video streams coming in from Teradata's Cafe in San Diego. You can see individuals being tracked. This is the real-time dashboard, being tracked in real time by tagged according to different activities, whether they're walking, whether they're queuing or engaging, and the amount of time they've spent in a specific regions. We also map them into a 2D CAD map, so there's a bird's eye view of where each individual is present. In a given location, we come up with, at the same time, we calculate metrics such as it's the total number of customers that are visible, their average visit time, the total number of conversions, the activities that they are exhibiting, as well as trying to forecast based on historical data what is the likelihood of customer visits over the next 5 minutes or so. That was the real-time component. For the bash dashboards, we can do this on a daily, weekly, or monthly basis. We have heat maps on areas of the store where have the maximum traffic. What's the conversion rate, or say average wait time at the point of sale over a specified time period? What is the dwell time in specific zones of a given location? This is path analysis to find the customer zone transitions from different paths or different regions of a location to the other one, so that we can identify areas where you want to do product placement, and you want to ensure that there are more eyeballs on the promotions that you're running. Now, that was on a standard retail scenario. What you see right now is an example on the same video streams, or how our models have been repurposed to provide COVID-based metrics, such as automatically detecting whether social distancing on the right is being adhered to or not. Whether as soon as someone comes within the minimum limit, they are tagged and an alert is generated, and you can see the overall social distancing violation ratio coming up, which gives you an indication whether, given the total number of people, what's the percentage who are not adhering to the social distance observances. So this was a quick demo on top of our cafe behavior on our cafe overhead video streams from our cafe. This is from a front-on video stream from the point of sale in the same cafe. Here, the objective is to determine how engaged are people with the advertisements or the information about specific products that are present above the point of sale. What people are looking at, what they're focusing on when they are engaging in sales, just to give an understanding of where the people's eyesight goes or gaze goes, to have relevant information placed for increasing associate interaction and increasing product customer interaction. Similarly, this demo looks at audience engagement in a classroom, seminar, or a training session. To see, it looks at things like poster, gaze detection, head orientation, to find how many people are engaged with the delivery that's taking place in front of them. So as you can see, automatically it tags people who aren't engaged at a given point in time, and who are attentive based on where they're looking at, what's their posture, and what's the orientation of their gaze. Just it's an enhancement of some of the features that I talked about. Some of the features that I talked about, such as staffing optimization, social distancing, that was pretty relevant to the current scenario. This is something that is an extension of how we can ensure, how we can detect and ensure customer engagement if required. So this was a quick overview of our demos. By now, I hope through the quick overview that I've done, that you have an idea of how we can get better answers from AI, and how even though AI has been hyped up significantly, it's already creating value if we know how to use it and how to apply it. And that by leveraging a combination of edge and cloud-based computing to average appropriately stage and process the observational data, we can unlock its real value. The value from this new rich metadata sets is truly achieved and enhanced when we put it into context, enabling new use cases that drive transformation business outcomes. Thank you. That's it from me. And I believe we'll be happy to take any queries now. Casey, over to you.
Thank you very much. Thank you for the Teradata team. Right now, we are open for any potential question and answer from the audience. If you have any question that you want to answer, you want to ask, you can unmute yourself and ask a question, or you can post it in the chat group. Right, we'll try to look at the question and then we'll answer it. If you have any question, you can unmute yourself. Or you can put it into the chat group. You know how to unmute yourself by the bottom of your WebEx session, right? There's an unmute button over here called mute or unmute. Okay, if there's no question, right, or if there any question, you can post it. If not, you can actually write back to Singapore Computer Society, right, for any relevant question, all right? And as mentioned, this video is recorded. I'm going to stop recording right now, and thank you for your time. Appreciate all the audience, and thank you, Teradata, for giving us this speech on vision analytic on the cloud. Thank you very much.
Thank you, everyone.
All right, bye.
Thank you, everyone.